Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 4, Lesson 15, Session 1. So it's the first lesson in Unit 4, and it's equivalent expressions. So the learning targets are write expressions with rational numbers in equivalent forms, expand an expression that includes rational numbers, factor an expression that includes rational numbers. Okay, so same or different? Well, we did this in class as a warm-up. 9b is as simple as it gets. These are called coefficients, and these are called variables. And when the variables are the same, you add the coefficient and keep the variable. So 6 plus 3 is 9, and then b. So a and b are the same. So 2 plus 5 is 7, and whenever there's no number in front of the letter, it's obviously 1b sitting here, so it's 1b. So 2 plus 5 is 7, plus 1 is 8. And this is 3b plus 4b, which is 7b, plus 2b is 9b. So we have a 9b, we have a 9b, we have a 9b, we have an 8b. So A, B, and D simplify to the same value, and C is different. One of the first popular and successful video games was available in arcades beginning in 1972. The game was an electronic version of ping pong. I think it was just simply called Pong, in which players moved a cursor to bounce a moving square across the screen. Okay, so that's what we're talking about. So in a certain video game, this try it problem, players earn bonus points after finishing a level. The number of bonus points is based on how many seconds T, let me highlight that. So T stands for time, seconds, time. It takes the player to finish the level. The game uses the expression, and it's this whole expression right here, okay, to determine the number of bonus points. Okay, so they're going to use this expression here. So we are in this chapter, we're going to start simplifying, and we're going to start working with expressions and equations that have variables and coefficients and constants and all those things, and we'll discuss those vocabulary words as we go. So Zahara finishes a level in 201 seconds. Okay, so that's the given information. It took her 201 seconds. So how many bonus points does she earn? So what the computer does is takes the negative 5.5 plus 500 plus 0.9 t. I'm going to change that t to a different color, so that's a variable, plus parentheses 11 over 2 minus 1.9. We've got another t here, close parentheses. So in class today, we were grouping that we were simplifying this, and I had a student say you got to do what's in the parentheses first. But when we have, this is called a constant. So a number all by itself, this, this, and this. Okay, they don't have the letter T next to them. They are called constants. Okay, so that's a constant, and that is a constant. And I'm going to go over all the vocabulary now. So a number that's being multiplied by a variable, or the number in front of the variable, is called a coefficient. Okay, so this is a coefficient, and so is 1.9. And then the t's are variables. Okay, so expressions and equations have coefficients, numbers in front of the variable, variables themselves, and constants, which are numbers added or subtracted without variables. Okay, so those are the three vocabulary words that we're going to be using. So let me just go back to here. Okay, and here's our equation. So since I can't combine these, I can get rid of the parentheses. So I'm going to just use my eraser here. So since this is plus, nothing changes beyond the parentheses. If this were minus, we would have to change the sign of everything in the parentheses by multiplying by -1. So I'm just going to erase the parentheses here because we had a plus sign. I kind of erased that a little bit too. So there it is. So the parentheses were not necessary, in other words. So now what I'm going to do is I'm going to combine. I'm going to rewrite this so that my variables are first. So it's going to be 0.9, and I'm going to keep that variable a different color for a certain reason. Okay, minus 1.9 t. So all I'm doing now is rearranging this and putting this and this first, and then I'm just going to start putting the constants in order from what I see, which is negative 5.5. And I'm going to change this 11 halves. Well, that's plus, it's positive. And 11 halves is also 5.5. Okay. And plus 500. So all I did here was rearrange this and put it in order. And what's going to happen here is we have a zero pair. Okay. Opposites. So 0.9 t minus 1.9 t, negative 5.5 plus 5.5 is 0. So we end up with just this plus 500 at the end. So see how this is starting to get simpler? Okay, we're simplifying this. And now we have 0.9 minus 1.9. Well, students are still struggling with negatives. You have to use a number line if you don't get it. Draw a number line just really quickly. And where is 0.9? Well, here's 0 and here's 1. So 0.9 is probably about here. So in order to get to negative 1.9, or if we move to the left negative 0.9, we're at 0. Well, that's only dealing with this 0.9 here. We still have another negative 1 to go. So this is negative 0.9 distance, and then this distance here is negative 1. So 0.9 minus 1.9 is a negative 1. And then they both had the letter t, so now we're just down to negative 1t plus 500. Okay, if you are not struggling with negatives, do not worry about doing the number line. You don't have to. That's just for those who are still not comfortable with negative or subtracting a larger number than what was started with. Okay, so the next thing I want to mention is when you have a 1 in front of a variable, you do not need to write it. You just need to write negative, because negative 1t is just simply negative t plus 500. Okay? So there's the expression as simple as we can get it. We have a variable and we have a constant. You cannot combine them. We're done with the simplification. But now we're going to focus on this, and it says how many bonus points does she earn if it took her 201 seconds? So it's going to be negative, substitute in that 201 for t, and then plus 500. Well, negative 201 plus 500 is the same as 500 minus 201, which is 299 points. Okay, so this game used this algorithm or formula to calculate scores based on time. And she got 299 points based off of this time. Okay. Okay, connect it. Look ahead. In the try it, you evaluated an expression. Sometimes it can be helpful to find an equivalent expression to evaluate instead. One way to find an equivalent expression is to use the distributive property. A. Sometimes you can use the distributive property to expand an expression. You can expand, I'm going to write this over here, negative 3 times 5 minus x into equivalent expression of this. Show how you can use the distributive property on this. So I'm going to explain the distributive property. And when I have a number outside the parentheses, it has to be multiplied by everything in the parentheses. So there are two terms in here, and terms are separated by operations of addition or subtraction. So the way I always want my students to do it is simply, just a second. Okay, so what I always do is focus on the sign first. What is a negative times a positive? It is a negative. What is 3 times 5? 15. Okay, it's as simple as that. What's this sign? Negative. What's a negative times another negative? It's positive. What is 3 times x? 3x. And that's what this is here. Okay, that is the distributive property. So in the example down below, it's now asking us to expand this. Okay, so you take -4 parentheses negative a plus 2. And it's the same process over and over. Multiply this times this. Negative times a negative is positive. 4 times a is 4a. Negative times a positive is negative. 4 times 2 is 8. So -4 times negative a plus 2 simplifies to 4a minus 8. And you can always check this by plugging in a number. Let's say a was 5. So this would be -4 and then -5 plus 2, right? And then if I simplify this, I can do the in the parentheses first. -5 plus 2 is -3, and a -4 times a -3 is a positive 12. Well, if I take that 4 and I used -5 to replace a, and now it's here, I can just put -5 right here, minus 8. Okay. I'm sorry, not -5, it's 5. So a was negative here, so a was 5. So this would be 4 times 5. My fault, my apologies. It's negative a in this, so that's -5. So 5 was my a, not -5. So 4 times a, 4 times 5 minus 8, and that would be 20 minus 8, which is also 12. Okay? All right, next question. B. Sometimes you can use the distributive property to factor an expression. You can factor 3z minus 6 to get the equivalent expression of 3 times z minus 2. Show how you can use the distributive property to factor 2g minus 10 to get an equivalent expression. So what I would do is I'd look at these two terms and ask myself, what will go into 2 and 10? What are factors of 2 and 10, in other words? So if you don't know what a factor is, if I have a number and I can multiply 1 and I can multiply 2 to get it, 1 and 2 are factors of 2. Well, if I have a 10, how do you get 10? Well, 10 is 1 times 10 or 2 times 5. So 1, 2, 5, and 10 are factors of 10. So when you do that, you look for a common factor in each, and it is 2. Okay? And that's where it comes from. So all you have to do is say, what will go into 2 and 10? Well, the answer is 2. You factor that out, and now it's just division. 2g divided by 2 is g. Negative divided by a positive is negative. 10 divided by 2 is 5. Okay? And there's an equivalent expression. So now part C says, can you factor -2x plus 6 and get -2x times x minus 3? Well, what can I factor out of this? I can factor a -2. You always want your variable positive because it's positive over here. So if I take out a -2, then I multiply it by x, -2 times x is -2x, and 6 divided by -2 is -3. So -2 times x minus 3, oops, I had an extra x over here. That should not be there. So there's the -2 times x minus 3. So are they equivalent? Yes. Okay, next page. Closing exit ticket. Explain why the expression -6 times the quantity 5 minus k and 6k minus 30 are equivalent. Okay, so there's an equation. So I'm going to distribute, and it's the same process over and over. Negative times a positive, negative. 6 times 5, 30. Negative times a negative, positive. 6 times k, 6k. Equals negative, equals 6k minus 30. Well, notice the 6k's last here. I can rewrite this. This is a positive 6k, so I can put the 6k first. And this is a minus 30, so I can put minus 30 second. And when I do that, when I rearrange them and put them in that order, they are equivalent. And that's the end of session 1. Hi there, Mr. Holcomb with another lesson in pre-algebra. This is Unit 4, Lesson 15, Session 2. Same learning target as Session 1, so I will continue. Which one doesn't belong? Well, if I rearrange, let's see, I have 5 minus 2c, and it should be negative 2c plus 5 if, in fact, I were going to put them in the proper order. Okay, so you always put the coefficient variables first and then the constants last. This is already in order. So obviously, as you can see, these two are not the same. Okay, when I add 2.5 and 2.5 and I add C to C, C plus C is 2C plus 2.5 plus 2.5 is 5. Now I have 2C plus 5. So these two are equal. These two are not. However, they all have coefficients of 2 and variables of C and constants of 5 being positive or negative, and this is all by itself a constant of 7. So which one doesn't belong? I would say it was D. Okay? Try it. Make sense of the problem. R negative 1/3 times all this mess and 2 times 1 minus 2m equivalent. Show why or why not. So the first thing we want to do is set them equal. So I'm going to write negative 1/3 times negative 3m plus 6. Why is my computer doing this? Minus 12 plus 15m equal to 2 times 1 minus 2m. That's what we're trying to find. Are they equivalent? So I set these two expressions equal to each other. Well, I'm going to come back over here and simplify, and let me highlight my like terms. I have a negative 3m, I have a positive 15m. I have a positive 6, I have a negative 12. Okay, negative 3 plus 15 is 12m. Or you could think of it as 15m minus 3m is 12m. 6 minus 12 is negative 6. So I'm just going to rewrite this. And actually, I could probably distribute this. 2 times 1 is 2. Positive times a negative is negative. 2 times 2 is 4m. So I simplified that. Okay. And now I'm going to distribute this. A negative times a positive is negative, and 1/3 of 12m is 4m. Negative times a negative is positive, and 1/3 of 6 is 2. And then I rewrite this in the proper order. Negative 4m first. This is a positive 2, so I have to say plus 2. Okay? So it's negative 4m plus 2 is equal to negative 4m plus 2. So they are equivalent. Number 6. Raul says the expression negative 25 times 1/5 x minus 20 is equivalent to this. Do you agree? Explain why or why not. So again, we're going to do the same thing. Negative 25 times 1/5 times x minus 20, checking to see if it is in fact equal to negative 5x minus 500. I don't need to do anything to this right here. I could factor out a 5, but let's just leave it as is. It's in proper order. It's called standard order, where we have a coefficient variable minus a constant. Okay, so let's look at this side. A negative times a positive is negative. 25 times 1/5 is the same as 25 divided by 5, which is 5. X. Negative times a negative is positive. 25 times 20 is 500. How did I do that so quick? 25 times 2 is 50 and throw a 0 on at the end. And now we have negative 5x minus 500. So notice we have a minus here and we have a plus here. So therefore, they are not equal. So you put a line through an equal sign, that means not equal. And your explanation is your work. So this explains why they're not. We're subtracting 500 on this side. We're adding 500 over here. They are not equal. Number 7. Okay, this one's going to take a little while. We have to do a bunch of calculations and make sure these are all equal, or find out which ones are and which ones aren't. So I'm first going to do off to this side here. I'll do this problem that they gave us. Negative 4 parentheses, negative 25y plus 4 plus 50y minus 8. Okay? First thing I'm going to do is simplify the inside. And let me highlight that. Like they're called like terms. So Negative 25y plus 50y are like terms, and a positive 4 and a minus 8 are both constants, so we can combine them. So negative 25y plus 50y is 25y. 4 minus 8 is negative 4. So this simplified down really nicely, pretty quickly. Now when I multiply this, it's a negative times a positive, which is negative. 4 times 25 is 100, and the y just comes down next to it. Negative, now I'm multiplying over here. Negative times a negative is positive. 4 times 4 is 16. So I am trying to determine which of these, is it 6, answers are equivalent to this. Well, negative 100y minus 4 is not the same as plus 16, so A is not an answer. B I have to do, okay? So I'm going to do that over here. I'm going to write negative 2, and I'm going to highlight over here just to save space. I have a 23y and I have a plus 27y, so let's calculate that first. I got my parentheses. 23 plus 27 is 50y. And then I'm going to switch colors and I will highlight my constants, negative 5 and negative 3. So negative 5 plus a negative 3 is negative 8, or negative 5 minus 3, however you want to say it. And now I can distribute this to here. Negative times a positive is negative. 2 times 50 is 100y. Negative times a negative is positive. 2 times 8 is 16. And negative 100y plus 16 is matching what this problem simplified to. So B is an answer. Okay, so I'm just going to erase this to get it out of the way because it's done and we're on to the next problem. So I'll do this over here. So the first thing, when you have parentheses, you can rearrange these and order the things in the parentheses in their own parentheses if they're like terms. And let me explain that. I have 100y here, I have 200y here, but I have a minus sign there. So let's address that minus sign first. Okay, let me just disregard that for a moment. Okay, and let me keep doing that. Okay, so I need to distribute this negative through this to get rid of those parentheses. So I'm going to take away these parentheses because there's nothing, they can't be combined, so why use the parentheses? We don't need them. So it's going to be 100y plus 32. Okay, no difference. But now this negative 1 times 200y, when I multiply this, negative times a positive is negative 200y. And a negative times a positive is negative, and 1 times 16 is 16. Now I can focus on like terms, which is 100y and minus 200y, and plus 32 and minus 16. So 100y minus 200y is negative 100y. 32 minus 16 is a positive 16, and this also matches. So C is a solution. Okay, now let me just erase this for the next problem. Okay, I just want to rearrange this. So this negative 100y will have to go first, and then this minus 16 comes after. Just rearranging it. And that's plus 16. This is minus 16. So since this is not the same, D is not a solution. Okay. This we have to distribute a negative. Negative times a negative is positive. 1 times 100 is 100y. Negative 1 times 16 is negative 16. Okay. So actually, let me put on the brakes right there. I should not be doing it. It's going to give you the same answer, but I really should be doing order of operations as well. And that says to do parentheses first. So let me just back up there. I'm apologizing for that. Here's 100y, here's 200y. We have to simplify our fraction first. That's parentheses in PEMDAS or grouping in GEMDAS. So now I'm going to say negative parentheses, negative 100 plus 200 is 100y. 16 minus 32 is negative 16. Then I need to distribute this negative. And when there's just a negative out there, think of it as negative 1. Negative 1 times 100 is negative 100y. Negative 1 times negative 16 is positive 16. So we then realize with this, it's equal to that. E is also an answer. Well, negative 300y minus 48 is not the same as this, so that is obvious, not an answer. So the answers were B, C, and E. Okay. And now it's your turn. So pause the video, see if you can do this on your own, come back and check. Okay, here we go. Are the expressions, these two, equivalent? So what do? I write 2 parentheses 3x minus 6 equals 2 times 3x, close the parentheses, minus 6 outside. Distributive property, positive times a positive is positive, 2 times 3x is 6x. Positive times a negative is negative, 2 times 6, 12, equals 2 times 3x is 6x. Be careful, this is not in the parentheses. It does not get multiplied by 2. You just bring down that minus 6. And since we have minus 12 here and minus 6 here, you guessed it, they're not equal. Okay, so that brings us to the end of lesson 15. Thanks for watching and have a great day.